Hey everyone. So we're all using these AI tools that feel like pure magic, right? But what's really going on under the hood? Today, we're going to pull back the curtain on the tech behind models like ChatGPT. And it all starts with one surprisingly simple question. So let's just ask it. What is a large language model, or LLM? It feels like this impossibly complex, almost living thing, a thinking machine. But the truth is actually way simpler, and in some ways, even more incredible than you'd guess. I love this slide because it just cuts right through all the hype. On one hand, you have what we all imagine, this mysterious, complex, digital brain. But the reality? It's almost shockingly simple. At its core, an LLM isn't a brain. It's just two files. Seriously, two files. That's pretty much it. One file is just a massive, massive list of numbers. We call them parameters or weights. The second file is the program, the actual code that knows how to read all those numbers and use them to generate text. It's a really simple recipe. The magic isn't in some convoluted structure. It's all about the scale. Okay, to make this real, let's look at Meta's Llama 2 model. This thing is running on 70 billion parameters. Just think about that. That's like 70 billion little digital knobs and dials, and every single one has been carefully tuned to hold a tiny piece of knowledge about the world. And all 70 billion of those parameters, they fit into a 140 gigabyte file. Now sure, that's a huge file. You're not going to email that to anyone, but it's a concrete thing. It has a size. This isn't some infinite mystery in the cloud. It's a single file that you could theoretically download to a hard drive. And this is the part that still blows my mind. That second file, the code that actually runs this whole 140 gigabyte behemoth, for Llama 2, it's only about 500 lines of C code. That is it. A relatively tiny little program is all it takes to bring this giant collection of numbers to life and actually have a conversation with it. Okay, so if an LLM is just this giant file of numbers and a little bit of code, that brings up the real question, right? Where do all those numbers even come from? How on earth do you create that file? Well, it turns out to be this fascinating two-stage recipe. The absolute best way to think about stage one of the training is to imagine you're making a lossy zip file of the internet. A normal zip file is lossless. You get out exactly what you put in. An LLM, though, is a lossy compression. It doesn't memorize the internet word for word. Instead, it learns the underlying patterns, the connections between words, the facts, and even the different styles of writing. It captures the essence of all that text. And this is a truly industrial-scale operation. We call it pre-training. You start by downloading an enormous chunk of the internet. We're talking about 10 terabytes of text. Then you use a supercomputer, a massive cluster of thousands of GPUs, to run this algorithm that squishes all that information down into the neural network's parameters. And what you get at the end of all that is what's called a base model. The scale here is just immense. For Llama 2, we're talking about 6,000 GPUs running flat out for 12 days straight. And the estimated cost for that computer time? Somewhere around $2 million. All of that just to create that one base model file. But here's the thing you have to understand. This base model is not the helpful assistant you're used to using. It's more like a dream machine for the internet. Its only goal is to predict the next word. It can generate incredibly realistic sounding text. It can write code. It can invent Amazon product pages. It can even write entire Wikipedia articles that seem totally legit but are completely made up. It's mimicking the style of the internet without any concept of what's true or helpful. So to turn that raw internet dreaming machine into a useful tool, you need stage 2, fine-tuning. This is absolutely crucial. Instead of the entire chaotic internet, you train the model on a much smaller, carefully curated dataset of high-quality questions and answers created by people. This process is what teaches the model to be a helpful conversational assistant. It aligns all that raw knowledge with how we as humans actually want it to act. Okay, so we know what they are and we know how they're made, but how do they get better? You'd probably guess it takes some brand new, clever breakthrough, right? But one of the biggest discoveries in AI is that their improvement is, believe it or not, surprisingly predictable. And this gets to the idea of scaling laws. Researchers discovered that an LLM's performance isn't random. It's not chaotic. It actually follows a smooth, predictable curve. As you increase the size of the model and the amount of data you train it on, its abilities improve in a way that you can actually measure and forecast. This predictability really comes down to two main levers you can pull. First, there's N, the number of parameters, which is basically how big the model's brain is. And second, there's D, the amount of data you feed it. The formula is almost simple. More N and more D predictably gets you a more capable AI. And here's the most exciting, maybe even terrifying part of this whole thing. These performance trends, they show zero signs of topping out. The graph is still pointing straight up. This means as we just continue to make these models bigger and train them on more data, we can expect them to keep getting dramatically better. We are nowhere near the ceiling on this. But the future of AI isn't just about getting bigger and bigger. It's also about getting smarter in fundamentally new ways. The next big frontier is about evolving these models beyond just simple pattern matching and imitation. A really great way to understand this next leap is to borrow a concept from human psychology: System 1 and System 2 thinking. System 1 is our fast, intuitive, gut reaction brain. It's what you use to instantly recognize a friend's face. System 2, on the other hand, is our slow, deliberate, logical brain. That's the part you fire up to solve a hard math problem. Right now, LLMs are absolute masters of System 1. They generate text incredibly fast, just based on the patterns they've learned. But they really struggle with tasks that require slow, multi-step reasoning. So giving these models a real System 2 capability, the ability to stop, think, plan, and work through a problem, that is one of the biggest challenges and most exciting areas in all of AI research today. So what happens when you combine this predictable path of improvement with these powerful new reasoning abilities? Where is all of this headed? Well, the vision that's really starting to take shape is for something people are calling an LLM operating system. Imagine this: a single AI that knows more than any human being. An AI that doesn't just talk to you, but can go browse the web for you, use your software for you, and actually get things done. It would see, hear, speak, and create. It could use that new System 2 logic to think about a complex problem for hours, or even cooperate with other AIs to solve it. This is the vision, a universal interface for our entire digital lives. So we've gone from a couple of simple files all the way to a future operating system for our digital world. The journey of the LLM is really just getting started. And all of this leaves us with one final, very big question. Once we actually build an AI that can know everything and do anything, what comes next?